My apologies. The pen works now, so we can proceed. Okay, so you guys just did this one on your own. What you might have noticed is that we are in a pretty good situation to use elimination on this. The reason for that is that these two y's are almost opposites already. All we got to do is multiply 1 by a negative 1. So I'm going to multiply this top by negative 1 and write my results down here. So that gives me a negative x, negative y, and it equals a negative 10. I draw my line, do my vertical addition. When I do that, my y's will cancel, and I have negative 2x minus another x. That gives me negative 3x, and it equals 7 minus 10, which is negative 3. If we divide both sides by negative 3, we will see that x equals 1. Is that correct? All right, thank you. All right, good. So if I have x equals 1, then I say, okay, I need to solve for y. So I have x plus y equals 10. If x is equal to 1, then I just have 1 plus y equals 10. Just leave me alone, Java. And subtract 1 from both sides, and I end up with y equals 9. All right, so our answer for that one is 1, 9. What? I have to write what?
Our answer is...
Oh, thank you. 1, 9. Good.
Good job.
Thanks, Gabe. And remember, if you want to check your answers on those, you certainly can. There's no reason for you to get this wrong on a test. You can just plug those back in and make sure that these equations are true when you plug them back in. All right, that's all you got to do. Quick plug in. Okay. So now we're talking about a basketball game. In this basketball game, the K-High Kings are playing, and they score a certain number of 2-point baskets and a certain number of 3-point baskets. The total number of baskets scored was 13. The total number of points resulting from these baskets was 36. How many 2-point shots and how many 3-point shots did the Kings make? Okay. So you don't have to fill out a table for these ones, but sometimes we like to. And we always just put the same thing in our side columns here. We put our
What is x going to be?
total baskets. I'll get that in a second. In the middle, we have our multipliers, and on the bottom, we have our total. We have our total points resulting from those baskets. This is, I meant to write like this. It's a new style. All right, so on the top, we're going to say our 3-pointers. We're just going to say X, because that's what we're going to label those. Our 4, wait, this is basketball. It's got to be a 2-pointer, right? Our 2-pointers, we're going to label that Y. And then finally, we have our totals. All right, since we've already defined our 3-pointers as X, we just throw that in there. Y is the same thing. And our total number of baskets, they said, was 13. In our multiplier column, we get 3 points per basket, so that's 3. We get 2 points per 2-point basket, so that's 2. And because this is one of those total value problems, there is no multiplier here. They already do that work for us. So now on the bottom, we multiply the top 2 entries to get the lower one. So I have 3x, 2y, and then they've given us the total points, so we just enter that in. They say the total number of points were 36. All right, so now we just sum across the top to create our first equation, x plus y equals 13, and then we sum across the bottom to get our second equation, 3x plus 2y equals 36. Okay, so we'll use substitution in this one, just because there's no decimals and I like that. I'm going to solve for y. So I'm going to subtract x from both sides. This gives me 13 minus x. Now I take that y and I plug it directly in for the y in the other equation. So the 3x drops straight down. Then I have plus 2y, but y is equal to 13 minus x. So I'm going to enter that in. And the whole thing still equals 36. Okay, so now that I've done my substitution, I only have one variable left to solve for, and this is exactly the situation I want to be in. So that leaves me with a 3x. When I distribute this 2 in, I end up with 26 minus 2x, and that's still equal to 36. All right, so now I consolidate my x's. I have 3x minus 2x. That gives me a solo x. And still plus 26 equals 36. Now I subtract the 26 from both sides. And that shows me that x is equal to 10. All right, so if x is equal to 10, go back and solve for y. So they say x plus y is equal to 13. If we have x equals 10, and we subtract 10 from both sides, then we'll find that we have y equals 3. Hello. So 10 comma 3 is our solution. Okay, and if we really wanted to check our work, we would just take 10 and 3, enter it back into these equations we came up with, and that would at least tell us that we solved our equations correctly. If you formed your equations incorrectly, that won't tell you you're correct or not, but it's a little bit of a check. Okay.
So for me, I got 3, 10, but that's because I made
A mistake?
2 points x and 3 points y.
Oh, yep,
Yeah.
that's fine.
So is that
Yeah.
still good?
That's totally fine,
I
yeah.
always pick the opposite variables usually, so everything is backwards.
Well, that one, I pay attention to that on the exam, and I don't expect you guys, I pay attention to what variables you're using. All right, so here we are.
A
Mixture.
problem.
Yes, yes, yes. Gary and his
We
fruit
missed
juice.
out on that last time.
We did, sort of. Well, we did one right at the end. Okay, so we have Gary and his fruit juice. Gary has 2 varieties of pineapple juice. Gary has a tropical mix that is 25% juice. Gary also has an Alaskan pineapple mix that is only 10% juice because our pineapples suck. Gary wishes to create 30 gallons of his new Southeast Special pineapple juice, which is 20% pineapple juice. How much the tropical mix and how much the Alaskan Special should Gary mix to get his desired 30 gallons? Okay, there's a lot of information in there, so we're just going to create a table and take it one step at a time. Just like always with a classic mixture problem, I put on the side column, I put our total on top. And for this, we're talking about volume of juice, so total volume. In the middle, I put my multipliers. And then on the last one, I put pure pineapple juice, or pure juice.
Or pure PJ.
Sure. So across the top, I'm going to list my types of things I'm mixing, and then finally, my mix. Okay, so let's see now. He had the tropical mix that was 25%. Trop, that is 25%. He had the Alaskan mix, the AK, which was only 10%. And then he wanted the mix. And the mix is supposed to be 20%.
Why can't it be 200%?
Because that's not what he asked for, and that's not possible. All right, so now that we've created our table, we definitely want to define our variables real quick, which is something I usually forget to do. So I'm going to say let x equal the volume of the tropical mix. Then I'm going to say let y equal the volume of the AK mix.
Cool.
Okay, so we have
Well,
X,
They're not quite mixed, so
we have Y, they are.
no, not the Alaskan and the pineapple.
So the tropical mix, right? It's a mix
Oh,
of juice and
that's-
water, right? We were
guess
taking
so.
2 mixes and we were making a 3rd mix.
I
That's
thought
good
it
though.
just said tropical juice.
Yeah, if it was that, then it'd be 100% juice, which is a strange problem to do. So now they said that they want us to create 30 gallons, so it's 30 gallons right here. Our multipliers, we just take our percentages and turn them into decimals. So I say 0.25. 10% turns into 0.10. And 20% for the mix turns into 0.20.
And we substitute.
Not quite. So on this next one, remember to create the final column, I just multiply the 2 above it. So 0.25x is the amount of pure juice contained in X gallons of tropical. And then 0.1y is the amount of pure juice in however many gallons of the AK. Now for the mix, since this is a classic mixture problem and not one of those total value problems, they haven't done this multiplication for us. We need to do it on this classic mixture problem. So the multiplication is 0.2 times 30, which I believe somebody just said was 6. Is that correct? Yeah, good. Yeah, so that's, remember, 0.2 times 30, that's how we get that entry here. But this is the actual entry. So now, just like with all of these problems that we put in the tables, we're going to sum straight across the top to get our first equation. That gives us x plus y equals 30 gallons. And then I sum straight across the bottom to get my second equation. And that's going to give us 0.25x plus 0.1y equals the number we got there, which is 6. We will not be doing substitution. And the reason is, like, I know I've said this before, but when you guys see a bunch of decimal places here, the easiest way to go is elimination, unless you love decimals. This guy here, substitution every time, right? Okay, so I don't know, I think, what am I going to choose? I'm going to choose the y's. The reason why I'm choosing the y's is because I can see that if I multiply this top row by 0.25 to make it match the x's, the 30 is not going to give me an even number, really. Even though the 0.1, actually, neither of them are going to give me an even number, so never mind. So I just choose the y's, and I say I need the opposite of this number. So I multiply this top equation by the opposite of that number, negative 0.1, negative 0.1. Whoops, what did I do there? So that should have been a 0.1y. Okay, so after I multiply that, I'm going to write it down here below. So that gives me a negative 0.1x, negative 0.1y, and that is equal to 30 times 0.1, which is 0.3, right?
Yeah.
Negative 0.3, thank you. Okay, I draw my line and I do my vertical addition. So the y's will cancel right off the bat.
Wait, is it a point? Is it just -3?
Oh, is it -3? Oh, sorry. Get rid of that guy. -3, thank you. Okay, so now I have 0.25x minus 0.1x. That's going to give me 0.15x. That is equal to 6 minus 3, which is 3. When I divide both sides by 0.15, that gives me 20. Thank you.
You and your calculators.
Plus in our pesky calculators, always calculating stuff with ease.
Yeah.
All right, so if x is equal to 20, then I can solve x plus y equals 30 by just subbing that in. So now I have 20 plus y must equal 30. If we subtract 20 from both sides, we see that y must equal 10. Okay, so what did we label as y? Y. All right, so if we really wanted to write this out, which we do on exams, we would say Gary needs 20 gallons of the tropical and 10 gallons of the AK mix. And you could end it right there. Alrighty. Any questions on that one? No. Okay.
Why didn't we do substitution?
Just no. No.
It makes a good 5 minutes of class experts.
Yeah, it does. Okay. Next. Square roots, square roots, square roots. Yay, yay, yay. So, for this guy here, I am going to extend the square root over both of these and multiply them together. So, I have under the square root 12 times 3. That is equal to 36. And we know 36 has an even square root. You don't have to do this on the exam, but this is how you would if you wanted to show your work. You would say this is equal to 6 squared, and then of course the square root of anything squared is just itself. Next. Now we have root 64 over 4. So, doesn't 64 have an even square root? It's 8, right?
Yep. 8 and 2.
So sometimes there's really no need to stretch this over both, right? I mean, they're both simple. We can simplify both of them right off the bat. This is 8, this is 2, the whole thing is equal to 4. That's it. Easy peasy.
Whoa. Sometimes, but it's not going to be like that.
288.
It's not.
I feel like we need a factor tree for this. Because I just don't know. So 288. Let's try 4 first. I think it's divisible by 4.
It is.
Right? 288 divided by 4. It is. So it contains at least one perfect square. 4 times 72 is 288. I should rewrite that. 72.
I believe that goes 9.
9 and 8?
Yep.
Can I get a second on that? I think you're right.
Divide it by 9, it's 9 times 32 equals 288.
What?
Yes. I liked 9.
Oh, okay. Yeah. Wherever you want to start is fine. That's, yeah. So here we have 8 and 9, right? 2 is prime, so it drops straight down. 2 is prime, so it drops straight down. 8 is equal to 2 times 4. 9 is equal to 3 times 3. We have one more drop to do because this is not prime yet. So 2 drops down, 2 drops down, 2 drops down, 4 splits, 3 drops, and 3 drops. So now I go through and I circle pairs. There's 1 pair, there's 2 pairs, there's 3 pairs. It's a good thing we did this. So, since those 3 are my pairs, the number I'm going to factor out is all those numbers multiplied together. So this first pair gives me 4, the second one gives me 4, and the third one gives me 9. 4 times 4 is 16, times 9 is what? Ah, excellent, 144. And so that is a perfect square number. What is that, 12 squared? Yeah. All right, so we found 144. Now we need to split that off from 288. 288 is equal to 2 times 144. So we have root 144 times root 2. The root of 144 simplifies into 12, so we do that. And the root 2 does not simplify, so we leave it. Okay, if we want to check our work and make sure, we can plug in the square root of 288 into our calculator. It gives me 16.97 something blah blah blah. And then I multiply 12 times root 2 and make sure it gives me the same number. The number is the same, so we are correct. All right, moving on. More fun with numbers. So for these ones, just like yesterday, we want to identify these. We want to identify them as either perfect square numbers or not, and then as either rational or irrational. Remember the definition to irrational. It's going to help you out on the test. The definition of rational is two numbers that can be put as a ratio of integers. If that cannot happen, then it's irrational. Okay, how about 36? Is this a perfect square?
Yeah.
It is, because 6 times 6 equals 36. So it's a perfect square, yeah. So, perfect square. So,
Different PS.
yeah, is this rational or irrational?
It's rational.
It's definitely rational, right? Any integer is going to be rational. How about the square root of 6? Is not perfect. Good. Is it rational or irrational?
Irrational.
Irrational. Remember, anything that's still in a square root that we can't simplify is irrational. Root 2, clearly this is not a perfect square. Not PS. And since 2 cannot simplify, this is an irrational number. And as a matter of fact, square root of 2 was the first irrational number that they ever proved existed. Strangely enough, back in the day, nobody really knew that irrational numbers existed. They thought that all numbers could be represented as ratios of integers. And the very first proof of an irrational number had to do with the square root of 2. It's a really impressive proof. So, how about the number 2? Is that a perfect square?
Yes.
No, not PS. And it's rational because it's an integer. All right, so how about 2 over root 2? It's irrational, right? Because this is a ratio of irrational numbers, so the whole thing is irrational. And of course, it's not a perfect square.
I need to get my head off of prime numbers.
Yeah, that would be good. I have one more for you guys. What about this? Is this a perfect square?
Is that supposed to be an absolute value of 8?
No,
Under
that's an 81.
Oh.
Is this a perfect square? Yeah, it is a perfect square because it's actually equal to the number 9, and 9 is a perfect square, right? And so it's not necessarily about the number inside the radical, it's about what the whole thing equals. Yeah, it's about what the whole thing equals. So yeah, this is a perfect square. And since it's only equal to 9, it's also rational. Don't forget that one. All right, next. Simplify. And of course, you guys all know that we do not count these as simplified fully until we've rationalized the denominator. And to do that, we just multiply top and bottom by the radical part of the denominator. So root 2, and this is just equal to 2 roots 2 on top, and then root 2 squared on the bottom, which just equals 2.
I think that's about it.
That's it. There we are.
That's funny.
That is a little bit of a weird one, isn't it? That's not what I was expecting. Okay, so this one, we know how to handle this because it has an even exponent. So we know that whatever pops out the other side is going to have exactly 1/2 of that exponent. But we do need to show our work on this, so this is how we do it. So we rewrite x to the 10th in terms of squares.
X to the 5th
Yeah.
size square.
Exactly. So we cut that exponent in half and put it inside a square, right, to show that we've rewritten it in terms of squares. And that's when we're allowed to pop it out the other side.
That really kind of gets me on the quiz, because my mind was so focused on perfect numbers, like prime numbers, that gets to determine whether it's a perfect square. I will end up thinking of it as a prime number instead of a perfect square.
Yeah, you gotta slow down, right? Yeah, you gotta know whether you're talking prime or perfect square, rational or irrational, have that definition in your head first.
Like
all right.
The 36, I was looking at it going perfect. I'm hearing perfect square, but I'm thinking prime, and I'm like, no, it's not a prime.
Yeah, it's good to work that out. Okay, so now we have 108 times root x to the 9th. So let's see now. 108, we're going to create another factor tree. 108 must be divisible by 4, right? I think it's 27 and 4. Let me check that because I'm not sure.
Yep.
Okay, good. So we have 27 and 4. 27 splits up into 3 times 9. 4 splits up into 2 and 2. The 3 is prime, so it drops. The 9 splits up into 3 and 3. The 2's are prime, so they drop as well. Now I come by and I circle pairs. I have a pair of 3's and a pair of 2's. When I multiply that all together, I get 9 times 4, which is equal to 36. Okay, so 36 times 3 is 108. I know the other factor has to be 3 because that's the only thing left over here. So on this next step, I'm going to split it up into those two factors. So I have root 36 times the root of 3. And then I'm going to split this exponent up, these variables up, because they have an odd numbered exponent. And we can't really simplify that. So we split off a single x, and we keep the next lowest even number. So we have x to the 8 now, times a solo x. All right, so next step. If we want to show our work on all of this, we can rewrite 36 as 6 squared, which I'm not going to demand that you show your work on the plain numeral ones, but it'd be nice on these x's. And then we have square root of x to the 4th squared. And then these two things I cannot simplify, so I'm going to put them behind, root 3 and root x. Now in the last step, I go ahead and simplify everything. So I have the square root of 6 squared, that just equals 6. I have the square root of x to the 4th squared, that just equals x to the 4th. And then these two things did not simplify, so I put them under the same square root and just leave them there.
Whoa.
Boom.
You're still trying to auto-read your stuff.
I know. 24/7. Okay. And I believe that's the last one. Any questions? No? Okay.
Yes.
And did everybody get a copy of the take-home packet? Oh, you didn't? Shoot, sorry.
Oh, okay, you even gave instructions. Come on.
Yeah, that's gonna screw me over on the test.
Yeah, careful. So yeah, I'll be in the Learning Center after this until 5. I will be gone tomorrow, Monday, and Tuesday. So the test, you gotta schedule it for Monday or Tuesday. If it ends up to where you don't have time to take it in one of those days, I'm pretty flexible and I'll let you take it in my office on Wednesday if you need to. You know, I'd rather you take it during Monday or Tuesday, but I like to give you unlimited time, and if you only have time for not enough, then let me know and you can take it in my office, okay?
So what's the difference between unlimited and indefinite?